Everybody happy with the just how to use the calculator and the things? So everybody's happy with how to get the points. Okay. So I recommend the points. The points probably here. You just verify them with -20 the first point. The second point was -1 what? Minus one. -17. Okay, -17. 0 4. 1 minus 3. 2 minus 8. 3 minus 4. Oh, sorry, 3 minus 5. And 4 something that's out of 412. So 412 being somewhere up here. I left it out just because it would make my diagram too large and harder to see the business end of the diagram, if you will. Now, the next one is the straight line. I'm set. The first point on my straight line would have been -2, -2 -9, which is the blue dot there, and then the end point would have been 6 5, and then all the points in between would be 3 1, 2 -1, 1 3, and 0 -5, and -1 7. Is everybody happy with all those points there? The blue one is the line. The red points belong to the curve. Most of you drew that out perfectly, so there's no bother there. Now, find two values for which f of x equals g of x. What does that mean? Two values of x. Where does the curve equal the line? So when does that happen? 1 and this one here. Okay, so yes, Dennis.
Is that just when x and g hit each other?
And f and g hit each other, yes, exactly. Now it says specifically the x values, Dennis, the two values of x. So the x values are up here. So one of the x values is 1, and the other one is somebody estimated at around 3.5, 3.6 maybe. 3.6. Let's go 3.6. Okay. So answer for part 1 is x equals 3.6 and x equals 1. Did anybody get those two answers out?
Yeah.
It's not 3 because 3 is here. They're not the same as at 3. They're two distinctly different points at 3. Okay. Now, next one. The range of values for which, what does this question mean? F of x less than or equal to g of x. Can anybody tell me what that means? Curve is smaller than the line. What does smaller than the line mean? Imagine there's two people. There's a guy who walks along the curve, and there's a guy who walks along the line. Who's above each other at the moment? Curve is above the line. It hasn't happened yet. But at this point here, they're at the same height as each other. The red walker and the blue walker respectively are the same height. Then just after that, what happens? The blue guy is above the red guy. That means hence the curve is underneath the line. Curve is underneath the line. This starts at x equals 1, and when does it end? So I'm just going to get the red guy is just going to continue walking up here. Blue guy continues on his path, and it ends at x equals 3.6. Now I would have told you guys yesterday, how do you write in maths numbers in between 1 and 3.6? 1 less than 3.6. Now, is it less than or equal? You go back to the top of your page and you look at it. This has an equal sign in it, doesn't it? The question actually has a less than or equal sign in it. So that means that you're going to need less than or equals.
I've got 3.4.
So it's with an error, you get full marks probably for that, right? You have a 0.2 of an error, so we could get maybe, sometimes the answer might be 3.5. So if somebody gets 3.3, they get full marks. If somebody gets 3.7, they get full marks. Okay. Because it's 0.2 either side of the real answer. Yeah. Okay. The main thing is just try and get as accurate as you can. Now, find the range of values for which f of x is greater than g of x. Same question, except what does it mean this time? What does it mean this time around? Curve's bigger than the line. So once again, go back to what we started with. When is the curve bigger than the line? Well, at the very beginning, which is x equals -2, is the curve bigger than the line? Is the red person above the blue person? So at the very beginning, so it starts at x equals -2. And then when does it end? It ends when he goes all the way up and back down over here, and the blue guy walks up, and now they're at the same height. So it officially ends at x equals 1. So any number underneath 1 will do you, won't it? So this graph continues on down this way. Oh, they will intersect again, so actually that is quite true. So what we're just going to say is that it starts at -2 and ends at 1. So how do we write that down? -2 less than x less than or equal to 1. Let's keep going on. When does it happen again after that? So at the moment the line is above the curve. Both people keep walking along, and then all of a sudden we end up back up here. They're equal again, and then finally the curve keeps moving up and the line moves up. So once again at this point here, what happens? It overtakes it again. So it starts again at, anybody? Starts again at x equals 3.5. Now here's a question: do you think the line will ever take the curve again? Look at the direction the curve's going in, and look at the direction the line's going in. I don't think it's going to get higher than it anytime soon. So one thing to note: when your graph is an x cubed, how many turning points does it have? X cubed has 2 turning points. Have the 2 turning points already happened? That means that this cannot possibly turn again. It's not going to turn again. So that means for the rest of this, your curve will always be bigger than your line. So any value bigger than 3.5, your curve is bigger than your line. So that's your answer there. Happy enough with that? Any questions? Okay. Next one. Yes, Dennis. Again. Okay. Now, what we have here, guys, is we have this graph here. Okay, so we have to put it into the calculator. Will people call out the points for me, please? -2, -8. Next one. -1, -3. -0, -2. Yeah. 1, 1. 2, 12. Okay. So what we're saying here is we're going to graph this graph here, right? So -2, 8 is down here. -1, -3, wasn't it? 0, -2. 1 is a 1, 1. And then it's gone up to 2, 12. And that's all you have to do, isn't it? Next, we're going to draw this graph. Done. We're now going to draw part 3 in red, or sorry, green actually. Okay, so when we draw this in green, we're going to get the following points. -2, was it -2, -4, -1, -5, 0, -5. Lads, what happens when you have 2 points that are level with each other? It means the turning point happens in between them. So if you ever have 2 points on the same level, it has to go up and back down again, never straight across. Okay?
You said that's not good. It's not good to do.
No. What I said was it's not good to do this. Draw like this. That's what I said. And yeah, I also said when it's symmetrical, as in when you have 2 points the same height as each other, the turning point has to be in between them and just ever so slightly lower. 0.5. 0.5, yeah. So you put in your 0.5, you find your extra mark there. You get 1 -4. You also get a 2, 2, 0. Now, use your graph to estimate the points where f equals g. Is that the only question? Yeah. F equals g. Well, that's very easy. You looking, Dennis? F equals g. The red dot here, that's the only one I see. So go straight up, and we need the point. The point would mean you need an x value and the y value. So what we're going to do is we're going to go up. What do you reckon about -1.7? -1.7, and then go across. And what do you recommend there? -4, in between -4 and -5. -4.4, I'd say. Now it's alright if you get a different answer to me. Like you can get, some of you could have 4.3, 4.7 even. Once you're in the ballpark. I did. Oh, you're right. Sorry guys, I went up in 2s. So because my scale is different, I'll have to adjust it. Roughly halfway between 4 and 6, I'll just call it -5. Yes, Sean?
My, like...
Here, okay? Just to really hit the point home. Okay, there we go. What we're going to do next, guys, is I'm going to ask you a question like this. When is f of x greater than or equal to g of x? When is the f of x function bigger than the g of x function? Okay, let's find out. Now, you guys would have only drawn, you guys drew from here to here, and you drew from this one here to this one here, because that only asks you to draw in between 2 and 2. So let's have a look here. Okay, so we have the green guy, which is the guy here, and then we have he's on the U-shaped curve. Do you understand that? He travels along this curve here. That's his path, so to speak. Okay, and then we have the other figure, which is represented by the black dots. He's going to be going this direction up here. Is that all right? Now, what we get is at the start, alright, they're both at x equals, let's say x equals -3, okay? So both of them are located at x equals -3. Who's above? Which one's above? Green is above the black, because the black is just underneath, is all the way, his graph is down here. So when you go to x equals -2, they're both at a closer height to each other. Then at this point we called -1.7, they're both at the same height. The y values are at the same height. I'm just talking about the y values. The y values represents the height. Because they're traveling along at... See, I'm basically traveling along the graph, Dennis. I have two graphs to travel along. See, there's two distinct graphs. There's a U-shaped graph and then there's the curved graph. Okay? So I'm trying to say is at the very start, they're both located, they both start off at x equals -2. Green is above black. Then they go to -1.7. Both of them intersect at -1.7. Then they go on to -1. And you can see that now the black guy, the black representative is above the green representative. Okay? Okay? And what it basically happens is f of x is the black path. Okay? So f of x is this curve here. So it starts at x equals 1.7, okay, and it ends at 2 because your graph ends at 2. So basically, the black path is above the green path for the rest of the journey. So he ends up here, while the green guy ends up there. So he's continually at he has a bigger y value. Yeah, and he's at a bigger y value. Okay. No, it's just a way of helping you represent it. Now, what we have here, guys, is bacteria can multiply at alarming rates. So what we're talking about, you have this in biology, you'll have 2 bacteria cells, okay, or 1 bacteria cell. And just see this function 2 to the power of x, okay? X means x is a unit of time. So at the start of your journey, at the start you only have 1 bacteria cell. After 1 hour, you have 2 bacteria cells. After 2 hours, you're going to have 4. After 3 hours, you're going to have 8. So what's happening is they're multiplying by 2 every second. That's quite common for bacteria to like just keep doubling over a certain time frame. This is actually used in biology in college. Okay, everybody look up this, please. Now, what you're going to have next is you're going to model this behavior on the function 2 to the power of x. Now, what 2 to the power of x does, if you look at this function here, you go to mode, you go to your table, and you put in 2 to the power of x. And because time can't be negative, guys, what do we have to start from? 0 to 6. 6, excuse me. Step of 1. And lo and behold, here's your points. 0, 1 is located here. Sorry, 1 second. 0, 1 is located here. We have our second point, 1, 2. We have 2, 4. We have 3, 8. We have 4, 16. We have 5, 32. And we have 6, 64. So this graph goes all the way up to 64. Yeah. So we can see that I'm just after drawing all these points here. Okay, that's all I did. Now, the way they might use this is, guys, they might say something like this. I'll give you an example question. How many? These are the amount of bacteria you have. So this the y-axis is the number of bacteria. So I might ask you guys a question. I go, how much bacteria do we have after I don't know, 3.5 hours? So how much bacteria after 3.5 hours? You go up to 3.5, you hit the line, and you go straight across, and you go off about 12 bacteria. Okay. If I ask you how much you had after was it 5.5 hours? You go to 5.5, you go across and up, and you go about 45. Okay. So that's how you can use this. Now, the other thing is these numbers. Do you notice that it's just getting bigger? It's just increasing more and more and more every hour because there's more bacteria multiplying. So the gap between 4 and 5 hours was only 16. However, the gap between 5 to 6 hours was 32. You see that it's constantly doubling. The reason why it's constantly doubling is it says 2 to the power of x. If the function was 3 to the power of x, what would be happening? Tripling every hour. 4 to the power of x, quadrupling every hour. Now, lads, after 24 hours, okay, what it's asking me at the start is, how much bacteria are you going to have after 24 hours? Well, the function says that you got to replace x with 24 because x is the time in hours. So it's going to be 2 to the power 24. Now, I can tell you right now that 2 to the power 24 is a pretty big number. So 2 to the power 24 because it doubles 24 times. So you're going to have a massive amount of, there you go, 16,777,216 bacteria after 24 hours. Okay, so that's how it works.